Greetings, everyone. I am Uday Sharma from the Tripoli Department of Institute of Aeronautical Engineering. Today, I am going to discuss about GPS receiver architectures, front-end and baseband signal processing. GPS or Global Positioning System is a set of satellites which revolve around the Earth. They can be detailed as the satellite network-based navigation system. GPS, in a layman's terms or common daily use terms, is often used in the navigation technologies and mostly used in driving in a aviation or military grade technologies to find out or to locate something. The GPS satellite weighs around 300 to 4,000 kgs and orbits around Earth 2 times a day. That is, it orbits around, it completes one rotation around Earth in half a day and completes another rotation and takes total two rotations to complete in a day. The term we often use as GPS is basically a GPS receiver. That is, every mobile or any GPS based navigation system or device we use is a GPS receiver, which the GPS receiver which locates four or more satellites at a time and figures out distance to each other and then chooses its own location. The GPS satellites are placed or orbited around the Earth such a way that four or more satellites can be covering a single area. Suppose there is a total area. There are at least four satellites which can cover the whole area and send the signals to the GPS receiver. The minimum of four satellites that send the signal to the GPS receiver to know its pinpoint accurate value. The GNSS or Global Navigation Satellite System is what we call this based off group of satellite system. The GNSS is a satellite system of how the GPS works. GPS receiver architecture. Let us see what are the multiple components or working units for GPS receiver. There are mainly categorized as 3N: radio frequency front end, signal processing unit, and local oscillator. Here, each unit has its own proficiency or usage. From the receiving of the GPS to analyzing the decoding and GPS signal does all the process. As we know, the GPS signal receiver, GPS receiver receives the signals. It analyzes the signals and the signal is compulsorily should be we don't know as what the signal means. So it should be decoded, analyzed, and shown us where are we or where we are going to be. The process can be detailed in the architecture. As we can see, there are multiple units: signal processing unit, this is a local oscillator, and external power supply. Receiving antenna or preamplifier. The receiving antenna is used to receive the signals from the satellites of the GNSS system. We will discuss more about the preamplifier part. We have a signal processor loop, precision oscillator, and a microprocessor is compulsory as we need to decode or analyze the given signal. The memory is connected with the microprocessor. External power supply is basically used to run this system, and command and display unit is used to interact with the whole GPS receiver. As a user, I need to interact with the receiver and know where I am going to be or where I am currently. External data logger is used to store the data. Let us see what is the receiving antenna. The receiving antenna, as you know, is an antenna of a GPS, which should be a very sensitive as it acquires a certain signal. This antenna receives the signal from the global navigation satellite system, and then the received signal is converted to the current signals. As you know, the received is an analog signal or any GPS signal, which is then converted into electrical signal So it can be powered the it can power the electronics. The electrical supply is given to the electronics, or electrical signal is given to the electronics. So they can be decoded. The antenna are of different types. There are of monopole, dipole antennas, spiral antennas, helical antennas. The radio frequency received from the antenna is connected to the RF front end. As we know, as we have seen in the earlier diagram, there is antenna and we have the RF front end. Let us see what is the RF front end. In the RF front end, we have a pre-filter, pre-amplifier, down converter, and A to D converter. The pre-filter is used to filter the distortions or disturbances. As you know, every signal comes with the distortions and the disturbances. So we use a pre-filter to filter out the disturbances and distortions. Then we pre-amplify the signal as it could be weaker, as it had traveled a lot of distance from the satellite to the receiver. Then we need a down converter. The received signal may be of different frequencies, but the required components we have, the electronics we have, works with a certain frequency. So a down converter is used to lower the frequency we acquired from the signal. And there is an analog to digital signal converter. So basically, we know that every analog signal is used to be converted to the digital signal. So the microprocessor can understand it and decode it. The microprocessor can understand it, decode it, process it, and analyze it, and show us the accurate output of our location. Here we can see the signal received may have lot of disturbances and noises. So they should be first filtered, and then the signal should be amplified. We have used the preamplifier to amplify the signal. Then the frequency should be downed according to the frequency of operation of electronics. As we have discussed earlier, every set of electronics have different frequency of operations. So we need to down the signal to the frequency of operations. The analog signal received then is converted to the digital signal for the electronics to work, or the by the microprocessor and all the rest of the electronics component in this GPS receiver. The converted digital signal is sent to the digital processing unit. In this signal processing unit, there are signal tracking loops. They are used to acquire signal from multiple channels. A channel can be simply defined in the way of communication, in the terms of communication, as a medium of way of transport of the signal. As we know here, this ADP converter gets sends this signal, and this is divided into different channels, which are medium of signal transportation. They are used to acquire signal from multiple channels. As the GPN location or data should be accurate, data is often used from multiple channels. More often, there would be at least 4 signal processing of the loops. And coming to the higher end tech, there are more of 12 or more channels in a single GPS receiver. Here, the local oscillator input is fed into the signal, or to say the digital signal is set to the reference frequency. The precision oscillator here is used to set the reference frequency. We'll discuss again how it is in the architecture diagram. As you know, the receiver receives the signal, it goes to the preamplifier, it gets filtered out at preamplifier and sets to a certain frequency, and then goes to the signal processing. Here, the precision oscillator sets a reference frequency as the signal processing. So the devices or microprocessors connected to it works in this reference frequency. So the preamplifier and the oscillator work such that the reference frequency is set and the signal is sent to the signal processing unit, the reference frequency only. Now, the core tracking loop and the earlier tracking loop is used to channel the data or to receive the channel data. Here, let us discuss about what the microprocessor and the memory or how this works. The microprocessor is used in the GPS receiver to control the operation of GPS receiver, that to control the signal, to process the signal, and to decode the signal. As we have discussed earlier, we need to control, process, and decode the signal to get an required value or required output location. Memories must be included in the unit as a microprocessor, as the microprocessor operations require some time memory to run or operate. An external source of energy is often given to the GPS receiver. Mostly, is a battery is connected to the receiver. It needs to power to be worked. As all the components here work accordingly, the GPS signal received and analyzed in the GPS receiver. Let us see what are the applications of this GPS receiver. We can determine the location, a pinpoint location which we use in the regular, for example, of Google Maps. Navigation, again, same thing as Google Maps. Tracking, as we can know as air tags or anything. We can track a certain object if we place a trackers in this required output. As we have a child, we can place a tracker in his bag. So based on this GPS location, we can track his movements. Mapping. Mapping can be related to the GPS navigation and location systems. Timing. Make it possible to take precise time measurements based on the GPS. We can also see applications of GPS trackings like logistics, municipals, rental cars, deliveries, drones, construction, etc. can be maintained quickly with the help of GPS applications. Thanking you. This is Sudesh Sharma signing off.